This is AP Calculus 2.5, the power rule. In this section, we're going to use that shortcut that I've been telling you about to find derivatives. And the power rule works for monomials. It works for something that has one term. But as you'll learn as we continue on with the rest of the unit, monomials can be combined, and if you have a polynomial, it's just as simple to find the derivative using the shortcut. So at this point now, the only time you're going to use the limit process to find the derivative is if the directions tell you to do that, or if for some reason the way the problem is presented, you can't do it another way, okay? From now on, anytime I give you something where you're finding the derivative, I would use the shortcut rule because it's going to save you a huge amount of time. Where every problem took about 5 minutes before, now you're going to be able to solve one of these in a couple seconds. So it's going to really take time off that you're spending trying to simplify these problems, doing them with the limit method. So here we have the derivative formula for the shortcut rule or for the power rule. And remember, d over dx means the derivative of, okay? So the derivative of x to the nth power, n is any real number, okay? The derivative of that is, what you're going to do is you're going to take that power and you're going to multiply it by the coefficient of your variable. So n times 1 is n, okay? And then we're going to decrease the power that we had by 1. So you multiply the coefficient by the exponent and get the number, and then you're going to keep the variable and decrease the power of that variable by 1. So the degree of a derivative is always going to be 1 less than the degree that you started with because you're subtracting 1 from the exponent that you had. Okay? So the derivative shortcut is going to be used now predominantly throughout the course when you have to find the derivative, or if it asks you to find the average rate of change, or if it asks you to find rate of change, the slope of the tangent line, the velocity, you will use the shortcut. Okay, so some examples. F of x equals 3x squared. I want you to find the derivative of that. So they're asking us to find f prime of x. To do that, I'm going to take the 2 times 3 is 6. I keep the x, decrease the power by 1, so it would just be 6x. For this one, negative 5x to the negative 2, I'm going to find the derivative of that. So this also works with negative exponents. Negative 2 times negative 5 is positive 10. We keep the x, and we decrease the power of negative 2 by 1. So negative 2 minus 1 is negative 3. Now remember, no negative exponents should be in your answer, so we would rewrite that as 10 over x cubed for our answer. So f prime of x is 10 over x cubed. And remember, if they ask us to find the slope of the tangent line at a specific value or a specific x value, we would just plug that x value into the derivative that we got. It is that simple. It's still going to be very easy to find the slope of the tangent line. The last example I have in this section, or this segment, is f of x equals 5x. Well, if I want to find f prime of x, I'm going to understand that that has a 1 for the exponent. So 1 times 5 is 5. And we keep the x. We decrease the power by 1. So that would be 5x to the 0. So now let's think about that. If it's 5x to the 0, do we need x to the 0 at all? We do not. So the answer to that one is just going to be 5. I have some more examples here. Sometimes when you have a function, you're going to have to rewrite that function to something that you can use the power rule on. So I'm going to first rewrite this one as f of x equals negative 2 times x to the 1/2. Remember, radicals can be written as fraction exponents, so you have to remember how to do that. And then I'm going to use the power rule. So f prime of x is equal to 1/2 times negative 2 is negative 1. We keep the x and we decrease 1/2 by 1. So 1/2 minus 1 is negative 1/2. And then I would rewrite my answer so that I don't have any negative exponents. So that would be a -1 on the top over, and then on the bottom we would have x to the 1/2, which is the square root of x. So I'm going to rewrite it that way. In this one, I don't have to rewrite this one. Understand that's a 1, so 1 times -3/2 is -3/2. The x will go to x to the 0, so that is just -3/2 there. And remember, the notation for the derivative, if your function is equal to y, the derivative would be y prime. For this one, I'm going to rewrite it first. That is, the 1/2 means it's 1/2 times that x, remember, to the 2/3, but since it was on the bottom, it'll be a -2/3. And then I'm going to use the power rule. So y prime, -2/3 times 1/2 is -1/3. We keep the x and we subtract 1 from this exponent. So -2/3 minus 1, that will be -2/3 minus 3/3, which is -5/3. And then I need to rewrite that one so I don't have any negative exponents. So my answer there would be y prime equals -1/3. You could leave that as x to the 5/3, or you could put -1/3 times the cube root of x to the 5th. If you leave it the cube root of x to the 5th, it's not in simplified form. Remember that x to the 5th, we can bring out an x. So if we put it back in radical form, we do need to go a step further and write it as -1/3x times the cube root of x squared. So I tend to save myself work and just leave it like that, okay? But either one of those is fine. Just make sure you don't leave it like this because it can be simplified. In this one, I need to rewrite that function as y equals 2 times x to the -2. If there's an exponent on the bottom, we need to move it up so that we can use the power rule. And then I'm going to multiply -2 times 2 for y prime, so that would be -4. I keep the x, I decrease the power of x by 1, so that's -4x to the -3. So y prime equals -4/x³. Okay? And for this one, I would rewrite that one as f of x equals 4/5 times t squared. That means the same thing. And hopefully you'll get to the point where you don't really need to rewrite it. You'll be able to just take the derivative and recognize that that is 4/5 t to the second. If you can already do that, that's fine. F prime of x equals 2 times 4/5 is 8/5. And t to the first, because we decrease the power by 1. So that's the power rule. It's that simple. It'll save you a huge amount of time. So from now on, when we do derivatives, use the power rule.